The largest pure endocrine gland. Two halves, and then an isthmus holding it together. Where'd they build the Panama Canal? Isthmus of Panama. That's right. You know how far it is across? Did I tell you before?
Say it's like 50 miles.
About 50 miles, Atlantic and Pacific. That's pretty close. Okay. Thymus. Yes, it does some hormones. I'm a little bit surprised it's here because it's not a big endocrine thing. Okay, but they have it here anyway. Thymus is big in the immune system, and you do get into it pretty heavy in AP2. So you'll see that in AP2. But at least we're mentioning it here. Thymus. It's down in the chest, not so much up in the throat. Okay. And then you've got these two what?
Adrenal glands?
These two.
Oh.
Kidneys?
Kidneys. And their caps are the adrenal glands. That's right, which are heavy into hormones and endocrine stuff. The kidneys, do they have any hormone that they make? The answer is yes, they do. I don't know why they had them here, maybe for that reason. I thought maybe it was just to have the caps on the kidneys have something to sit on. But it could be that. What hormone does the kidney make?
Does it make that, the one that makes you go to the bathroom?
No.
No, it's on the.
Erythropoietin?
Erythropoietin.
Oh, we,
Erythropoietin. I'll write it here. There it is. Erythropoietin, a hormone produced primarily by kidneys, and it causes the production of erythrocytes, red blood cells. So they come from where?
the kid,
They come because of the kidneys, but they come from where?
Red blood cells.
Yeah, where they come from.
oh, the red bone marrow?
Red bone marrow, that's right. All of your blood cells, as an adult, they come from the red bone marrow. And
So the
they-
kidneys send a signal to the red bone marrow to create more erythrocytes?
Yeah, and the signal is this hormone, erythropoietin. Erythropoietin. Can you get erythropoietin given to you by your doctor? Probably can. Yeah, you can if you're low on blood. For instance, you've been pretty badly anemic, then they may give you erythropoietin. So that's pretty neat. The kidney makes the hormone, but they can actually produce erythropoietin and give it to me, yeah. They do. Somebody who's really low in blood, say, has been in an accident or something and got low in blood, they might give them erythropoietin to help them start producing more. Okay.
You know the volumetric rate that the body produces blood, roughly?
I don't know what it is, yeah. Good question, how? Remember, red blood cells have to be replaced because they wear out faster. Okay, how many days was it for a red blood cell's life?
180?
I'm trying to remember what we said. It's about 120 days, which is not a long time. Why is a red blood cell not lasting so long?
Because the nucleus was removed.
They spit out their nucleus, so they're not gonna be as hardy. That's right. Why they do that? They self-sacrifice for what purpose?
To transport oxygen.
So they can carry more hemoglobin, which carries more oxygen. Okay. Yep. It was self-sacrificial. They did it for that reason. And who gets all these dead red blood cells or these worn out red blood cells?
The spleen.
The spleen. So it's nicknamed
Red cell gradient?
red cell graveyard. Yeah. Red blood cell graveyard. Okay. So we don't waste it. The stuff gets recycled. Okay. So you can make more. Because you're always needing to make more. If they only last 120 days, you know, we're just through January. how much, ones that were here for the beginning of January, how long do they have left?
3 more months?
90 days.
9 days. They would be ready to be replaced when? This is if it was January, they'd be replaced in
April.
April, probably April. And then you do it all over again. I mean, you just keep replacing them, okay? Because they only last 120 days. And that was on average. All right, so we did all these except we didn't finish down here. This would be your largest pure endocrine gland if it were
Purely.
pure. But it's not, it's what?
Endocrine and exocrine.
Yes, endocrine and exocrine, so we call it a mixed gland. And exocrine needs to get out of there. How would you get exocrine stuff out of there?
Or a duct.
Through a duct, D-U-C-T. And so pure endocrine gland, thyroid, doesn't use a duct, it doesn't need one. But pancreas is not pure, it needs a duct for its exocrine substances it makes, digestive enzymes. Where would they go?
Small
Small intestine. How would they get there?
pancreatic duct.
Pancreatic duct, exactly. We get into that in AP2 when we do digestive system.
I have
Okay,
a
yes,
question. For AP2, are you using the same textbook?
yes.
Okay.
And same lab book too. Yeah, that was changed recently, otherwise you had to get a new one. So that was good. And we've got some gonads, which make,
Sex hormone.
gonads make
Gametes.
gametes, that's right, what are gametes?
Sex cells.
Sex cells. Male is
Sperm.
sperm cell, female is
Ova.
ovum, plural,
Ova.
ova, okay? And gonads make them, so who's the male gonad?
Testes.
Testis, plural,
Testes.
testes. Female,
Ovary.
ovary, plural,
Ovary.
ovaries, okay? So this is showing us both, to get through that. And we have to go up to the head because there's stuff going on up here. When you think of endocrine gland in the head, who is it you probably think of first?
The pineal gland.
That's not what I think of first.
Pituitary.
Who would you think? Pituitary? No?
Hypothalamus.
We'll think about pineal gland. The pituitary gland, who works in combination with
Hypothalamus.
hypothalamus, who runs whom? Hypothalamus runs the pituitary. Okay, so hypothalamus is the boss. Then we got another gland called pineal gland. Where'd they get the name?
Because it looks like a pine.
Looks like a pine cone, right? Okay, so that gets us oriented here. What's pineal gland make? Melatonin for sleep. So when would it be released? When would it be released? When would it be secreted?
At night.
At night, most likely. And so if you get up at night, turn on the lights bright, could you interfere with this?
Yes.
Just keep that in mind. Don't fall over something, you don't want to break your leg or something, but blasting out your melatonin may not be the best idea. Because then you go back to bed and you can't go to sleep. You can't go to sleep, that's no good. Okay, what do we have here? We've got pages, 2 pages, 610 and 611. So here's a picture of where we are. We're up in the brain. What's the part in the back? Cerebellum. Cerebellum. We're gonna do brain, we do it in chapter 12. Okay, what's the cerebellum do for us? Keeps us coordinated, smooth moving. Can you move without the cerebellum?
Yes.
If it got damaged, yeah, you can move, but it's gonna be jerky. It's not gonna be nice and smooth, at least in most cases. So here we have this. We have the white ear on its side. You'll get that in chapter 12. Down here is the pituitary hanging down from the hypothalamus. So how does it hang down? It hangs down on a stalk called infundibulum. Infundibulum. So they show you the posterior pituitary here, and you could say posterior lobe, but nobody does. Posterior pituitary, anterior pituitary, and they wanted to show you both of these because one of these doesn't produce any hormone on its own.
Look off there.
Posterior does not make any hormones. But it has two hormones in it. Where'd they come from? Hypothalamus above puts them in the posterior pituitary and then says when to release them. That's nice. Okay, who are the two hormones? Oxytocin and antidiuretic hormone. Oxytocin is well known for labor contractions in a female who's giving birth. If the baby doesn't want to come out, then what do? Give them Pitocin, and they'll change their mind at that point. And the contractions are supposed to be fairly strong. Okay, at least some people maintain that. Antidiuretic hormone, ADH, is for what?
Going to that, regulating body fluid, urinary,
Yeah, trying to keep you from dehydrating. Okay, when a person, a lot of times it's an older female, but it might not be, says, I'm on a water pill, what is it called? It's a diuretic. And why would they do that?
remove excess fluid
Excess fluid, like where?
in the leg.
In the legs, the ankles? See, it, maybe, but I don't usually hear that. What else? The arms, they might have it there. What about around the heart? Would that be a pretty serious situation to have fluid around the heart? Yeah. So around the heart, and other places, excess fluid, give them a water pill, a diuretic. But this is anti-diuretic, which means opposite, keep you from urinating, because you don't want to dehydrate, okay? What if you're in the Sahara Desert visiting for some reason? Maybe you were at the pyramids and got lost or something. Say, okay, I'm not gonna urinate because I'm in the desert. Good luck, it's not gonna work. Everybody that's healthy has to urinate each day. How much?
A liter.
How much minimum do you have to urinate each day? 500 milliliters, which is half a liter. You know how liters look in the store with soda and all, half of that each day. Can't get out of it because if you're healthy, you have to get rid of metabolic waste, and that's about what it takes to do that. Okay? So you say I had good intentions, but it didn't work out. Okay? Now we wanted to look at this from a little more perspective here. This is posterior. So hypothalamus sends these strands down into the posterior pituitary through the stalk called the what again? Infundibulum. What are these strands?
Axon.
Axons. This is a bundle of axons coming down here, and they drip out the hormone that you're supposed to store here. And so that means you have a pathway down through here with the axons. On the other side, you have a pathway here with blood vessels. So they're not the same, okay? What's a bundle of axons called in the brain or spinal cord? A bundle of axons in the brain or spinal cord. That's the central nervous system, brain and spinal cord. What's the bundle of axons called? Everybody got quiet. What?
Is it motor unit?
No? Well, we're going to name this pathway right now. What's the pathway's name? It's hypothalamic hypophyseal tract. So what's a bundle of axons in the central nervous system? A tract. And this is where you first meet up with that. Later on in the course they say, okay, where did you first meet up with a tract? Can you tell me? Hopefully. Not everyone has. Okay? Hypothalamic hypophyseal tract. Where did they get that name? Hypothalamic for hypothalamus. And hypophyseal? That one's not so obvious. Okay, let's go back to our note sheet. Oh, it's not there. We need to get it. Let's see. There we go. So here's hypothalamus. There's pituitary. Its technical name is hypophysis. Hypophysis. If you think that's your science fair project, it's not. That's hypophysis. Okay, this is hypophysis. Hypophysis. So the technical name for pituitary is hypophysis. And so when we saw that name before, let's see where we saw it. We saw hypothalamic, hypophysial, which means pituitary. So hypothalamus, pituitary tract, that's what they were saying. Hypothalamus to hypophysis tract. Any questions? Let's come over here, because the pathway down is not a tract. It's not. Okay, over here, it's the hypophyseal portal system. Hypophyseal portal system. So you say, what's a portal system? Anybody remember? Did we discuss this? Well, you'll remember now because I'm going to discuss it. Portal system. All right, think about your body. Think about your heart pumping out blood through
Veins and arteries?
veins and arteries, but from the heart.
From the heart to the pulmonary.
Leaving the heart.
The
Arteries. What's the biggest one? Aorta. But then it's going to branch into smaller and smaller arteries, and finally they'll get tinier and be called,
Blood
Capillary.
no, not yet. Capillaries are the smallest blood vessels. Let's see if I got rid of it. Yeah, I might have. Let's see. There was erythropoietin, so I probably got rid of it for that. Let's write it in.
If you click back and then we'll do the last thing.
Oh, well, yeah, I'll just do it this way. Thank you for the guidance. Arterioles. What are arterioles?
Small arteries.
Small arteries. Arterioles are small blood vessels that carry blood away from the heart. There you got it. Okay. And they're going to take the blood finally to the tiny ones. Capillaries. Those are the smallest blood vessels. How small are they? Some are so narrow that a red blood cell, which you can't even see with your naked eye, has to bend to get through. Talk about small. Okay. Well, these are arterioles. They're not that small, but they lead into capillaries. And you're just full of capillaries. You got capillaries all over the place. Capillary beds. Okay. So you get into arterioles who are finally going to connect with the capillaries. And then the capillaries are going to connect with
The portal system.
you're trying to read into that. It's not working. That's right.
Back.
Venules. What are venules?
Small veins?
They are very small. Can anybody read it?
Small veins.
Veins, they're little veins, venules. So that's the normal course of things. You go from arteries, finally to little arterioles, to capillaries, to venules. But we're not doing what everybody else does. We're going from venules to capillaries. So what? Why are you going from venules to capillaries? Because of what we're looking at here now. That's not normal. That's abnormal. What do they call it when you do that? Now's the time to say what we said before.
Portal system.
Portal system. So if you go from capillaries to venules, you should go on to bigger veins, but instead you go back to some capillaries. That's a portal system. So when we go back to here, we're going to see right up here. You see, that's what's happening here. We got a portal system. So we're going to name this pathway to the anterior pituitary. We're going to name it hypophyseal for what? Hypophysis, the pituitary's name. Portal system, because we got a portal system there. Okay. Do you realize this is like very honoring to the hypothalamus? This is the boss's direct line to the anterior pituitary, little blood vessels. Okay. What do you think the hypothalamus is going to send in these blood vessels?
Hormones.
Hormones, because you can secrete hormones into blood. If you can't do it, then they're not hormones. That's right. So we have our very own little portal system here. the hypothalamus, the boss, has a direct line into the anterior pituitary. And what would the boss be saying to these cells in here? Release your hormone. So what kind of hormone is that going to be to send to them? Release your hormone. Releasing hormones, of course. And sometimes the boss may say, no, 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 don't. Then the boss sends inhibiting hormones down. Either way, the boss, the hypothalamus, wants to send hormones down here to tell the anterior pituitary what to do. Releasing hormones, inhibiting hormones, and you need this nice little blood vessel network. You say, well, you got a lot of blood vessels out in the body. Yeah, but you send some hormone out to that, by the time it gets going through your big toe and everywhere else, it's like, boy, that would take quite a bit of hormone to get around to everybody. So private little blood vessel network, that's the ideal. That's exactly what you'd like to have. So even though they could send it out through the whole body, why not just send it directly to the place you meant it to be? Any questions?
So the hypophyseal portal system is like a closed network.
It's kind of closed. It's direct to the anterior pituitary. So the hypothalamus can directly tell the anterior pituitary release hormone or inhibit hormone. It's very nice for that. Hypophyseal portal system. So we have two pathways through the infundibulum. You should know both of them and what they're called. Any questions? Now this is not for Thursday, but it is for the test, so make sure you got it. Any questions? Yes. I have to go back and look. It's not Thursday, because Thursdays are lab practical. Yeah, I have to look at, let's see if we got that. Yes, we got a syllabus. Yay. Maybe it's not so yay once we look. Okay. It says this is week 6. Oh, look at that. Tuesday of next week, test 2. And something to think about. Think hard on. Okay, so Thursdays are lab practical. And we're probably, it says muscle fascicles and levers. We're probably going to do chapter 5 instead, because we haven't done that. And then you'll be getting ready for your test. So it's pushing us some, but we're going to do it. So test 2 is next week on Tuesday. Think of that, 1 week from today. Test 2. Kind of helps you relax, doesn't it? Yes.
I was just wondering when our first lab will be, like our actual lab where we're like doing stuff.
Check your syllabus of the calendar of activities.
Okay.
But you've been working labs with these models, and you're going to do some today again. I consider those labs. They're not wet labs though.
Mm-hmm.
But when the wet lab comes, you better have your coat and your goggles and that sort of thing. Okay. Otherwise, you're not permitted to participate. Okay. Yes.
Okay, so going back to what we were talking about, the anterior pituitary gland has the portal system going to it, and the posterior pituitary gland has all the axons.
Has the tracks.
Okay.
Track.
The tracks.
Mhm.
So the anterior pituitary doesn't have tracks? Or
It doesn't have tracks.
Okay,
Because that would be axons. It's not doing that. It's blood vessels.
yeah, and then the posterior pituitary
It doesn't have
the portal system.
it doesn't have blood vessels.
Okay, cool.
There are blood vessels around because you're going to secrete hormone, but they're
Right.
not in that pathway yet.
Okay, that's good to know.
Good questions, good clarification. Okay.
And that tract in particular doesn't have a specific name, it's just a tract.
The tract that we were talking about, according to our book here, they called it the
Oh, the hypothalamic, hypophyseal.
hypothalamic hypophyseal tract, which, if you want to hold on to points, might be a good thing to know. Okay? You should know that. And it says it right there, hypothalamic hypophyseal tract. Over here, for the other one, it wasn't a tract, it was a hypophyseal portal system. And now you know what a portal system is. Right?
What about that picture makes it a portal system? Just because it's traveling into veins?
Well, this is kind of narrow in here. So they're going supposedly from capillaries to bigger, well, they don't do a great job of showing this, but to bigger blood vessels that are still tiny little veins, but then you go back to capillaries before you go on.
Okay.
So this is not all capillaries, I don't think. Might be, but I don't think. It says, well, let's take it back. It says secondary capillary plexus, so primary capillary plexus. So you do have capillaries. A plexus is a group of capillaries. So yeah, you are actually getting into some little capillaries in here. So we went from capillaries to venules to capillaries, so it's a portal system. Okay. Oh, who's being made down here in the anterior pituitary? Growth hormone. Remember the name for growth hormone?
Somatotropin.
Somatotropin. Somatotropin. We should be able to write that. Maybe. Doubt it. Somatotropin. Growth hormone, human growth hormone, is also known as somatotropin. If you were wondering, it's 191 amino acid single chain polypeptide. Is that impressive? Maybe not too much, okay? So that's what growth hormone is, human growth hormone. It actually stimulates some other things that are insulin, I'm trying to think, insulin, something, okay, that actually makes you grow.
Insulin-like growth factor.
And that's it, insulin-like growth factors, okay? But anyway, somatotropin is the other name for growth hormone, and I do want you to know it. I do want you to know it. Well, we're not done with that. I keep trying to turn the page. Okay. So let's see what you think of that. So, somatotropin, growth hormone, that's from the anterior pituitary. How about talking to the thyroid? How does the anterior pituitary talk to the thyroid? By TSH, of course. What's that? Thyroid stimulating hormone. So the anterior pituitary secretes thyroid stimulating hormone, and how does it know where to go?
It just goes all over.
It goes all over. Wherever the blood goes, it goes, and then the thyroid goes, huh! It gets stimulated.
Oh.
So the target knows, the hormone doesn't know. Okay? In case you wondered, how do they know where to go?
It's kind of like shooting a key that only fits into one lock,
And then
right?
it hits in the
A little bit.
Water.
Yeah.
It hits in the water.
Only the ones sensitive to TSH are gonna respond.
The thyroid.
Yes.
Who does it talk to?
Talks to the thyroid and says, you need to release your hormones. And the thyroid says, oh, I'm being told to release my hormones by the anterior pituitary. Okay, I'll do it. Yes.
I have a question about the axons. That's the yellow thing, right?
Yeah, the axons are coming down in the posterior one. They're not coming down here.
Okay.
Okay.
It just confused me because it shows them.
Yeah, they
there.
showed them, which is kind of reminding you, but
Mhm.
that's really posterior. And
Okay.
that would be your hypothalamic hypophyseal tract.
Got it. Thank you.
But that's only posterior,
Got it.
okay? So now, who else? Well, the adrenocorticotropic hormone, ACTH, guess where that's going?
Adrenal gland.
Adrenal, cortex. So it's not the medulla, it's the cortex that's gonna respond. And we wanna look at that in just a little bit, okay? Then there's follicle stimulating hormone. Guess who is getting talked to in this one?
Hair.
How
Scalp.
about gonad? Yeah. Guess who else talks to the gonads? Luteinizing hormone. So these two are going to gonads and they're going to go, huh, because they're going to respond to it.
Stop doing that.
The FSH is going to make the gonad do what? Release the sex cells. That would be like,
Huh?
Menstruate.
no,
Oh, hormones.
Gametes. Which gametes? See, I can come up with good questions, which makes you not worry about the test, because I can come up with good ones for that.
Releasing ova and sperm.
Ova and sperm cells. So gametes make, gonads make gametes, so it fits in. So what hormone fits into that? FSH, follicle stimulating hormone, promotes gamete production in gonads. Well, what does LH do? It promotes sex hormone. So that would be like testosterone, who else? Estrogen, who else? Progesterone. So those are gonna come from gonads too. But LH is the one going to encourage that. LH does one more thing. It's kind of impressive. Every month, a young female will do what? Yeah, not that though.
But
Ovulate. What promotes ovulation? LH. LH causes ovulation once a month. So that would be, of course, gonad. Ovulation. Egg cell pops out. Ovum is released. Okay. LH is what's doing that. How about a new mother? What's she need? Lactation. So prolactin encourages her to produce milk.
what did we? Oh, sorry.
Go ahead.
What did we say about the?
I'll take it.
Oh my gosh!
Go ahead,
I'm so
I'll take
sorry.
it.
What did we say about the follicle stimulating hormone?
Follicle
Because the
stimulating
gametes?
hormone causes gametes
Okay,
to be made. LH causes sex hormone.
got
Does
it.
that mean that, FSH doesn't really do much in females after birth? Cause aren't the ovum all matured at birth?
Well, they're there,
Right.
but you're gonna get rid of a whole lot of them by atresia. There's a whole lot, bless you, there are a whole lot of early on egg cells that are gonna not make it. They're gonna be reduced way down, and you still have a lot. But the female is born with all the egg cells she's gonna have, and then they will continue to be gone. So it works its way down, but you still have a lot at this point, okay? Oh, you had a question?
I was gonna ask, is that like the only thing prolactin does, is like
No,
produce-
but they don't know what all these things super do. So we take some of them and we can at least say, well, it does that. So prolactin produces it. There's also some other stuff they've talked about, but it's not, I can't just point it out real easily. Yes.
You mentioned that the luteinizing hormone.
Yes.
I'm sorry if I butchered the name.
No, I thought you did a pretty good
Produces,
job of it.
the ovulation, right?
It will promote ovulation, that's right.
So if you were to inject someone with that, could you extend ovulation forever? Like for,
Well, no, and here's why. The ovulation is only an ovum that's ready to pop out. You don't have a lot of ovums ready to pop out. They have to build up and go through development and be ready to go, and the LH causes it to finally pop out.
okay.
So it won't keep doing
Oh.
that, okay? Anybody else? We got a lot out of these 2 pages, didn't we? I think so. So skipping over a little bit here, you can read it. I've got a family one of my family pictures I wanted to show you. This is back a ways. See this? You can tell this is a long time ago, right? Okay. This is Big Daddy, and this is his wife, and the little kid, see, isn't that touching how he's holding on to the little kid's hand, okay? Until you realize the little kid has a mustache and is smoking a cigar. And then somehow the family thing starts to fall apart. This is actually somebody who's a gigantism from having too much growth hormone. When he was little, Cause if he's too old, it won't do this. Okay? If you gave growth hormone to somebody who was already having epiphyseal lines, they won't do that. What do you get when you do that? That's the wrong one. Let's see.
Something negative.
I think you did well to remember that. Let's see where it is. Maybe further down here. I'll type it if I have to. Acromegaly, there it is. Acromegaly. You give somebody growth hormone after they've stopped growing, then they can't grow anymore. They've got epiphyseal lines, they can't get any longer. But some parts will grow, go ahead and grow some. Your jaw will get bigger and more rugged, your wrists and your ankles will get more rugged, and we call that acromegaly. Acromegaly. So growth hormone when you're an adult, not a good idea. However, there are people that are actually taking human growth hormone because they think it helps them. And they could end up with acromegaly. I've seen somebody, I suspected it on TV, thought they probably had gotten into that. Okay, yes.
When does your growth plate harden? Like when does it fully harden?
Well, it's usually like late teens for females, or not too far from that for males. They go a little longer because they start later. Males don't grow as fast as females right at first, and so they last a little longer than that, and then they stop too.
Interesting.
Yeah, usually for the males in elementary school, it's quite a come down when the females are taller than they are. Yeah, that happens. Okay, but not forever. The males will start to catch up and surpass probably. Okay, so acromegaly, we got that there. So we saw the picture. Oh, I meant to tell you this too. She's the only one that's normal. Did everybody get that? She looks short, but she's really the only one that's normal there. And if you think it's great to be real tall, look at what he's using. Yeah, people that are taller a lot of times end up having back problems. Not always, but a lot of times. Okay, and there's no way to make this pituitary dwarf taller. He's done for that because his growth plates have all hardened into bone. But it's a good picture. It's a real nice picture to make you think about it. What we have here is the thyroid connected by the isthmus, right? Okay, what bone is this?
The
Hyoid bone. What are these blue things?
Trachea? So the ring of the trachea.
Those are
It's
hyaline
a trachea,
cartilage.
what, hyaline cartilage rings, that's right, okay? This is the candy cane that goes around and back behind the heart. Aorta. And if we want to look at the thyroid, which we do, we would look in the thyroid, cutting and using the microscope, and we find these pink lakes. They're not normally pink, but they're pink here. Those are called follicles. Follicles. The only one that has the follicles in it of the endocrine glands is thyroid. Has these follicles, and the cells are out around the lake. Each one's around these little lakes, okay, around the follicles.